Good morning everyone and welcome to chapter 7. In this chapter we'll take a look at equations and how to solve them. We already did this in chapter 3, but this time we'll be taking a look at quadratic equations. So without further ado, let's start the chapter. Let's start by refreshing our memory. What is an equation? An equation is a formula for which we already know the answer. So something like 3x plus 4 is equal to 25. And solving this equation means we need to figure out for which value of x the formula is correct. In chapter 3 I told you about the balance method. 3x plus 4 is 25 means that 3x must be equal to 21. 3x is equal to 21 means that 3 times a number must be equal to 21, meaning x should be equal to 7. This was a linear equation and there are many variants possible. Here are some more equations to jog your memory. In paragraph 7.1 we'll be taking a look at quadratic equations. The simplest one is x squared is c, with c being a number. So, for example, x squared is equal to 25. To solve this equation, we need to figure out which number we need to fill in for x to make this formula correct. If your immediate answer was 5, then your answer would only be half correct. That's because x can also be minus 5. Because minus 5 squared, meaning minus 5 times minus 5, is also 25. So in this chapter you can have two answers for your equations. And the equation x squared is 81 has the solutions x is 9 or x is minus 9. I say or because you can't fill in both numbers at the same time. When solving the equation x squared is 45, you might want to use a calculator. Simply calculate the square root of 45 to receive 6.7. So the solutions to the equation are x is approximately 6.7 or x is approximately minus 6.7. However, it is possible for an equation to have zero solutions. Let me bring in the equation x squared is equal to minus 16. To solve this equation, I have to take the square root of minus 16, and that poses a problem, because I'm not allowed to take a square root of a negative number. That means our equation has no solutions. But what if we add some more numbers? How about x squared plus 10 is 59? To solve this one, first subtract the 10 from both sides to remove the plus 10 on the left hand side. We now have the line x squared is 49. Lastly, we take the square root of 49 to receive x is 7 or x is minus 7. And to solve 2x squared is 32, we first have to divide both sides by 2 to receive x squared is 16. We remove the square by using our root function and end up with x is 4 or x is minus 4. Those were the easy ones. On to some more bigger problems. The equation 5x squared minus 12 is equal to 33. We solve this equation by following the rules of the balance method. First we make sure that all the numbers are on the right hand side. So we add 12 and receive 5x squared is 45. Then we divide by 5 to receive x squared is 9. Finally, we take the square root of 9 to receive 3 as our answer, meaning x is 3 or x is minus 3. As a side note, instead of writing the word or, I use this symbol. This V is the mathematical symbol for the word or. On to the next equation. Minus 3x squared plus 8 is 116. We again start by making sure any loose numbers are moved towards the right hand side. I see a plus 8, so I do minus 8 on both sides. I receive minus 3x squared is 108. I don't care about minus 3x squared, so I divide by minus 3 to get rid of it. I now have the line x squared is minus 36. Next up would be to calculate the square root of minus 36. But because that's a negative number, I stop here and write down no solutions. Instead of just putting the equation out there, we could ask you to make it yourself. For example, like this. Here you see a sketch of a parabola and a horizontal line. Your assignment is to figure out the coordinates of points A and B. To do this, you have to make the quadratic equation by using the given formula. The parabola follows the line y is minus a half x squared plus 5. The horizontal line is placed at a height of 3. To find the coordinates of A and B, solve the equation minus a half x squared plus 5 is equal to 3. We solve this equation using the balance method. Minus 5 on both sides, divide everything by minus a half, and then take the square root of 4. This gives me x is 2 or x is minus 2, meaning the coordinates of A are minus 2.3 and B's are 2.3. Why? Because A is on the left / negative side and B is on the right / positive side. If your equation contains brackets, hold on to those for as long as possible. So, as a final example, let's take a look at this equation. 1/3 x minus 4 squared plus 7 is 34. We first subtract 7 to receive 1/3 x minus 4 squared is equal to 27. We then multiply by 3 to erase the fraction. We now have x minus 4 squared is equal to 81. We remove the square by taking the square root. This gives us the line x minus 4 is equal to 9 or x minus 4 is equal to minus 9. To get rid of the minus 4's, just add 4 on both sides. We end up with x is 13 or x is minus 5. Another way of solving quadratic equations with brackets is to replace the brackets with a so-called shadow equation. So instead of solving 1/3 x minus 4 squared plus 7 is 34, we solve 1/3 u squared plus 7 is 34. The steps to solving this equation are exactly the same as before. We remove the plus 7 from the left-hand side of the equation, get rid of the 1/3, and calculate the square root of our answer. We now have the line u is 9 or u is minus 9. As u was substituting for x minus 4, we replace the u for its original format and receive x minus 4 is 9 or x minus 4 is minus 9. We add 4 to counteract the minus 4 and end up with the 13 and the minus 5 as we did before. And with that, we've reached the end of this paragraph. During this chapter, we'll be continuing solving quadratic equations, so be sure to keep practicing and honing your skills. In the next video, we'll take a look at factorizations. This is essential for future paragraphs, so be sure to tune in next time for an all-new episode of Teaching Math. Bye bye!